Well, according to YouTube, there are two people watching. I didn't really think through how I'm going to identify who anyone is. For all I know, these could be alumni from previous years coming back to watch. That wouldn't be the first time that's happened. I am hopeful that the chat's showing up on the right-hand side for people to ask questions. Because then people can put in requests and tell me if the microphone's too loud. Oh, 4 people now. Now, I know I started it up early, but I figured that anyone who was here could queue up some questions if they had any. I also wanted to make sure I'd have the opportunity to troubleshoot any issues, because this is honestly the first time I've tried to pull off something like this. Always wanted to try it, but never really made it happen. So the tricky thing for me is uh, I see a chat window. I'm not sure if, of the 4 people who are actually watching it right now, I don't know who those students are, and I don't know if they can see the chat, and if they can hear me. Um, I don't know if they're actually able to input anything. If the chat's not there, it's not like you can type in, "Hey, we can't see the chat." There's also a high chance anyone who is watching this is watching on their phone, and I also don't know what the chat screen looks like there. So, oh, look at that. Thank you, Donald. If anyone is noticing, there's a bit of a delay between um, when I'm actually saying things and when it's actually broadcasting. It's maybe like a 5 to 10 second delay. So please don't be offended if you ask a question in the chat if I don't immediately respond. It's because there will be a little bit of lag time between when I see it and say something about it and then when you'll actually hear it. I was testing it out because I had it open in another window, and I was always hearing myself on this really awkward delay. That's a nice reaction, Michael. Is the woohoo for math or the woohoo for the snow day? I wonder. All right, so we've got Donald and Michael here. Who are the other two? Or do Donald and Michael just have it open in 2 windows apiece? By the way, guys, if you want to start queuing up questions that you'd like to see me do, if there's a topic or something from the textbook. So I'm sitting at my computer at home. I've got a few different monitors up. One of them has the textbook up. So if you have requests from the text, then I can pull questions from there and we can go through those. Oh, there's Anna Boat, person number 3 of 4. um, it keeps moving away from OneNote every time I click to something else. That's gonna get frustrating. And a 5th person has joined in with 9 minutes to go until our official start time. Uh, okay. Hi, Cam. Or what I'm assuming to be Cam based on the username. Everyone else has done full names. Cam's using an online alias. And just so everyone's aware, while we're doing this, so my office is in the basement of my house. So occasionally you might hear the furnace kick in. My microphone, I've noticed, is very good at picking up quality audio, but it'll also pick it up at a good distance, unfortunately. You can probably also hear my chair creaking in the background. It's an old office chair. In fact, I don't think I have access to any office chairs that don't creak. Um, Even the ones at school need some oil on the parts. Oh, thanks, Donald. Offering to donate. I'm doing this in my role as your teacher. There needs to be no additional compensation for this. The final noise disturbance I was going to prime you guys for is that the cats might make noise in the background. For whatever reason, they're both down here sleeping in the basement, and one of them is aggressively headbutting me to get my attention because I don't think he likes the idea that I'm sitting at the computer doing math instead of paying attention to him. So if you hear him kick up a ruckus, or far more likely for him knock something over, um, yeah, that's what's happening. Oh, okay. So Anna's in with the first request, practice exam, paper one, question seven. Um, so let me see here. Just got to pull that up in a separate window. Okay, so for you guys, your practice paper was last year's mock exam, right? Question seven. Now, the tricky thing here is because I scheduled this time and it was kind of for both groups. There may be some times where I'm doing a question that's really only applicable to DP2s, and other times where the DP2s will look at it and maybe will think it's a little trivial because it's for DP1s. Um, I figured there was no ideal way to kind of manage that because I wasn't sure how many people were even going to show up for this, so I thought it was better to get people here all at the same time than separate them. All right, so this is the question that Anna is asking about. So I've got that one on the list. Uh, yes, Cam, I know that's you. Is that everyone that's checked in then? No, Donald, Michael, Anna, Cam. There's a fifth spectator still who is apparently choosing to be silent. That's okay. Okay. Um, DP1s, I don't know if you have questions that you want to queue up and get ready to ask. I'm going to tackle this one with the DP2s for now. What time is it? Oh, we're not even at 1 o'clock. Well, whatever. We'll start early. I'm pretty sure. Oh, is Sophia watching with you, Anna, or is Sophia the fifth person? Um, anyway, while Anna's answering that question, oh darn, I lost track of what I was going to say. Whatever, it'll come to me. Oh, right. So as I do this question with the DP2s, DP1s, if you guys want to put some questions in the chat that you would like to do, so either if it's from the practice paper, just throw it in there and say, practice paper, whatever, question two. Or if it's from the textbook, just give me section, page, and question number, and then it'll make it easier for me to find it and screenshot it to put it in. So this one is about a binomial expansion question. So Donald and Michael and any other DP1s who might pop in and try to watch this from the beginning. We haven't done this yet. We're doing this after the exam, so this is kind of off your radar. You don't have to worry about this or look at this and say, gosh, should I know what I'm doing here? Because the answer is no. You don't have to worry about it. So looking at this question, we're going to need to use the general term of a binomial expansion. The binomial expansion that we're given here is just missing the exponent. So so 3x plus 1 to the n, I don't know how many times I'm multiplying 3x plus 1 by itself. Now, we know that n has to be a natural number, or, well, they said over here, it has to be a positive integer. It's technically the same thing. Um, and so we know that that's the number that we're going to have to solve for. We know that it can only fit into a certain range of values, so we're not too worried about having infinitely many things to look at here. And then they tell us that the coefficient on the term with x squared is 135n, and that's going to be really helpful to us because as soon as we pop this into the general term, we're going to need that information to actually get anywhere. So in the formula booklet, I think I've mentioned this many times before, but I suppose, is important to reiterate. That's the general term of a binomial expansion. So t with a subscript, whatever that number is, represents the term of the expansion. Like if it was t2, that's the second term of the whole expansion. That formula is in your formula booklet, kind of. I would say that in sort of an emphasis in italics or something. It's kind of there. It's not explicitly stated. There's not something that if you read down that left column, it's going to say a general term of a binomial expansion. It's that one where they show you how to do the binomial expansion and the general term's right in the middle. So you really have to remember where to look for it. But this is what we're going to be using for this question. And realistically, anytime you're doing a binomial expansion question, your gut instinct should be to go to this, because even if you don't know what you're doing with the question, there's a pretty good chance that it involves this somehow. And so you just have to write that out as a good starting point and then take inventory of what information you actually know. So we know that A, the first term in the expansion, is 3x, and we know that B, the second term in the expansion, is 1. So of that binomial, the first term is 3x, the second term is 1. Those are the two key pieces I'm going to need to assemble this general term. Now, I rarely know R. Usually, we don't know R. It's something we have to solve for a little bit later. And in this case, we're actually trying to figure out N. So finding R is usually a step toward solving for that sort of final piece of information. So I don't know N, but that's my final goal. And I don't know R, but presumably there's a way to figure it out as we go. So if I set up my general term accordingly, there are only certain things I can actually plug in here. 3x in for A, and well, for B, I just put in 1. Now, there's still a lot of variables here. It looks really complicated, but the reality is parts of this can start to simplify, or at least simplify well enough. And so I'm going to leave the n choose R out in front. Not going to touch that yet. We'll circle back to it in a minute. I'm going to split up that 3x. So I'm going to apply the exponent to each part of that product. So it's going to be 3 to the n minus r and x to the n minus r. And 1 to the r is really easy to resolve because 1 to the exponent of anything is just 1. So I'm actually just going to take that out of the running because I don't even need it at this point. It's just going to clutter things up. So what I have here is essentially the coefficient of this term and the variable portion of this term. Right? I recognize the variable portion because it's where the x is, and I recognize that front part is all numerical. Yes, there are n's and r's there, but n and r represent numbers. I don't know what numbers they are yet, but they're still just numbers. So this is the coefficient of the term. And so knowing those two pieces of information, I can basically form two equations here that are going to help me solve the problem. The first one is this. That variable portion, x to the n minus r, is equal to x squared, because that's the information that was given to me earlier in the question about one of the terms I'm going to be looking at. The coefficient of the term in x squared is 135n. So I know that when I have x squared, the coefficient is going to be 135n. That 135n is going to then help me with another equation, because I know that n choose r times 3 to the n minus r, that's going to be equal to 135n. So that's helpful to me too. Now I think probably where the difficulty arose with this question, if I had to venture a guess, is that we're still not at a point where we can directly solve for r. Or or at least that's my suspicion. I think that's where people are at, where you're looking at this and you're thinking, yeah, this doesn't necessarily make things a lot easier for me. How is this helpful? I don't know what R is. I just know that from this first equation, I can say with confidence that n minus r is equal to 2. I don't know that I can do much more right away. And it's fine to think that. I mean, there's a reason why this was question 7, which I've said to you guys is typically the hardest question of Part A on the IB exams, and is usually a pretty challenging thinking question. This one's not meant to be like you just set those exponents equal and then the value of r falls into your lap. This one is supposed to be a little bit more challenging in that way. So what I would observe from this, and you have to admit, I've done the question before a few times at this point, but what I would observe as a student is I notice here that there's a value of n in that equation on the left-hand side. So 135n is on the left-hand side of that equation. There is no r there. And that to me sends a pretty clear signal that what I need to do on the right-hand side is get rid of r. Like there's got to be some way to sub something in for r and get rid of it, so there's only n, so that presumably with a little bit of algebraic working, I can get to the left-hand side where there's only that n. And that's where this equation comes in, the n minus r equals 2. If I rearrange this, I get that r is equal to n minus 2. So whatever the r value is, it's 2 less than whatever the n value is. And so that's going to be helpful to me, because if I substitute that in to this equation, and again, the left side's not going to change, but the right-hand side can now become n, choose n minus 2, and that's going to be multiplied with 3 to the n minus 2. And if you're scratching your head then and saying, well, I really don't feel like that's a whole lot better, we need to simplify a little bit here first. And then you'll kind of see how things tidy up nicely. So let's start with that exponent on 3. We have 3 to the n minus 2. If I distribute that negative into the brackets, the n's are going to wipe each other out. I've got an n, a minus n, tidies itself up nicely, and leaves behind only the exponent 2. And so 3 squared, that's a little bit easier to manage than 3 to the n minus r, right? That's something that's very easy to grapple with. On the left-hand side, I still have 135 times n. Now the n choose n minus 2 piece is probably the biggest hurdle to clear here. So this is going to actually require that you use the definition of choose notation. Now, this isn't something you have to know from memory. This is something that's also in your formula booklet. It's probably just something you haven't paid a whole lot of attention to because, to be honest, it rarely comes up when we're solving problems in SL. You rarely have to go to that equation, but it is there. I'm not 100% sure how it's written in your book, so I'm just going to write out one definition of it. I'm going to hope it syncs up. But when you're doing n choose r, that's the same as doing n factorial divided by n minus r factorial times r factorial. So in an instance where you had, let's say 5 choose 3, we would calculate that by doing 5 factorial over 2 factorial times 3 factorial. And that's how that calculation actually works. Now, we talked about that when we first learned it in your DP 1 year. But then, again, didn't really use it too. I think it's maybe come up, and I think I'm being pretty generous in my estimation here. I think it's maybe come up twice over the past 2 years. And so, to that end, you haven't really used it too much. But if you ever get into this situation where you've got choose notation with only variables in it, then that's what you're going to gravitate to. So, keeping that in mind and moving back over to the equation we're actually working with, I can take n choose n minus 2, and I can write it as n factorial divided by n minus 2 factorial times 2 factorial. Right? So 2 here is in the place of that r that I'm seeing. And so I can work with it that way. So n factorial over n minus 2 factorial times 2 factorial. It's nice to see now the requests are coming out of the woodwork for questions. This is good. That means we're going to have a lot of stuff to work on after this one. Anyway, so with tidying this up algebraically, factorial, hopefully you remember that n factorial is equal to n times n minus 1 times n minus 2, all the way down to 3, 2, 1. You're multiplying from n through all the natural numbers until you get to 1, and then you stop. That means I can expand the n factorial in the numerator by kind of opening it up there, but not expanding it fully, because that would be impossible. But expanding it enough that I get to the point where I have the n minus 2 factorial in both the top and the bottom. Because once I've done that, I can actually divide it out. I don't need that in there anymore. It's clearly on both the top and the bottom. I can tidy that up a little bit, and then I should be all set to deal with something a little bit simpler. Because with that gone, I just have n times n minus 1 over 2, and all of that's times 9, which I'm not sure why I haven't evaluated up until now. I think I was so focused on the factorial, I wasn't thinking of the simpler stuff. And we have to remember, too, on the right-hand side, we've done a lot of algebraic working. On the left-hand side, we haven't touched anything. It is still equal to 135n. And so this is starting to get a little bit less complicated at this point. It looks like it might work out to be a quadratic, but I think you'll see it actually doesn't even go that far. If I divide by n on both sides, because it's there and there, this tidies up even a little bit nicer. I get, well, let's multiply the 2 over as well. We'll make this 270 is equal to 9 times n minus 1. And so this is actually just a linear equation at this point. 270, I divide it by 9. That's easy enough to do. 27 is a power of 3, so is 9. So hopefully you see that that's going to divide nicely. We're going to get 30 is equal to n minus 1. So therefore n is equal to 31. And so the question here, I know it's very complicated at the start. It was probably difficult. Actually, I would be curious to know for the 3 DP2s, I think, who are here, how far you made it through the question, because setting things up with the general term of a binomial expansion, so this part on the left, I don't know why I put my pen down because I need to highlight this part here, that should be your go-to for any binomial expansion question, without hesitation. Like, you should flip to a page and see it's a binomial expansion question and just write that stuff down without even knowing where you're going, because it's necessary that you're going to use it, and it's usually worth like a mark or two, so you might as well, right? It lets you process the question while you're just doing the introductory level work to get things sorted. And so that should always be the starting point. I will concede that the algebra here is really complicated. But as long as you remember that for any binomial expansion questions, all the stuff that you need is on the formula booklet. Just try to make sure that you're being resourceful and saying, okay, well, what do I need to simplify? And how do I move on from here? The real tricky piece of insight is the thing that I mentioned back at the start of this step, which is recognizing that on the left-hand side there was no r value, and therefore I need to get rid of the r value on this side. That was sort of the big thinking piece of this question. It's one of the reasons why I liked it so much, one of the reasons why I included it on the the exam in the first place. And so anyway, that's how that worked out. Yeah. So I don't know anyone if anyone has any follow-up questions for that one, any of my DP2s. I'm pretty sure the stream, as I'm looking at the chat, I think it's still catching up to where I am now because of the delay. And I don't know what's going on in the chat with messages being retracted. What is this about? I don't know if this is you guys doing this or if this is something YouTube is doing automatically. Behave yourselves. All right, let's take a look at what people were asking for next. So I think Michael had a question in next. Review set 2B number 9. And I think I saw it pop up in the chat. He had another one too. Yeah, 3B. So number 9, number 3B. I'm just going to go find those in the textbook. Michael, if you could give me a page number for those, it would be helpful. I'm guessing somewhere in the late hundreds, perhaps, or mid hundreds. Oh man, nope, not even in the 50s. Oh, when will this cough go away? Just out of curiosity, for those of you who are here, did everybody get the email from the school about exams being rescheduled and everything like that? It came to me, and at the top it hinted that I was getting the email because I was a grade 8 homeroom teacher. But then I'm not sure if it only went out to parents. So maybe your parents are all sitting on the details of how your exams have been rescheduled or what. But I just thought I would ask. If you haven't seen it, then I guess that's okay. If you have, then you already know what's happening. I can fill you guys in, though, if you're really curious and you have not received any information. Oh, I don't like how these are coming out so blurry. I'm going to try and screenshot that again. Okay, so Michael's asking a sign diagram question for 3B. And the other one was number 9, I believe. Number 9. Okay. Inverse functions. That seems fair. Okay. Yeah, Jack, I saw your request for practice paper 1. I will get to that one, and then I'll circle back to Cam's question from DP2. So we'll do a few DP1 things here, and then move back to DP2. Okay, let's do the sign diagram question first. So this is the function in question that we're being asked to draw a sign diagram for. Whenever you're drawing a sign diagram, the whole thing that you're focusing on is the domain. You need to look at what x-intercepts there are within your domain, and you need to look at any interruptions from the domain. So when I say interruptions, I mean that there's discontinuity, that x can't equal a value, and therefore you should not be considering those values within the domain, right? Because when we draw our sign diagram, the sign diagram is the horizontal line is just the x-axis. That's what it represents. And so when you start to mark things off, you're marking off where you don't have x values that exist, right? That's what you're doing with your asymptotes. And you are also marking off basically what would make the function go from being above the x-axis to below. So if I look at the equation for this one, I look at the denominator to find my vertical asymptote. I see that x cannot equal -5. If I do that, I'm dividing by 0, and that's a major no-no. And so I'm going to mark that off on my sign diagram, I'm going to say this is negative 5. And that's going to be the first thing that I've labeled there. Now, you do dotted lines for vertical asymptotes. You'll do solid lines for x-intercepts. So then I have to ask myself, okay, what are the x-intercepts of this? And this one might be tricky because it's a rational function plus a linear function, and I suspect, if I'm willing to guess, anyone who's done this question and struggled with it, you probably had an x-intercept listed as x equals -9. That would be what I would guess, which unfortunately means that you kind of ignored the linear part of the equation. Sorry, I'm pausing for a second just because, for whatever reason, one of my cats has decided to go behind the desk and chew on some cords. Animals. She just crawled out from behind the desk looking very ashamed. Okay, back to this question. Oh, good grief. So the tricky thing here is if you only look at the numerator and you're just thinking that this is like an ax plus b over cx plus d situation, then unfortunately what you're missing is you're missing a very crucial piece where that's actually not what's in the numerator. In fact, the numerator is a quadratic if you actually work it out. So x plus 9 over x plus 5 is equal to, or not equal to. Thanks, Michael. This is such a bizarre way to interact with a class, I've got to say. Because it has this weird blending of social media tropes with school. Michael could never actually respond to me with an emoji if we were in the classroom. At least, God, I hope that never happens. Anyway, what I've taken is I've taken that x and I've put it with a common denominator with the rest of the function. So now I need to simplify a little bit on the top. We have x plus 9 plus x squared plus 5x. And that's all over x plus 5. And if I were to simplify this, I get x squared plus 6x plus 9 over x plus 5. Now, seeing a quadratic there in the numerator. Oh, hello, Ian. And I also don't know who Gator Tater is. So hopefully that person can identify themselves. They're saying review sheet, which suggests to me DP2. But I'm not sure who that would be. Anyway, this quadratic in the numerator, I'm going to have to factor it. Now, it's an easy one to factor, thankfully, so we don't have to do too much work to get that done. X squared plus 6x plus 9 factors to be x plus 3, all squared. And so I can see from that my x-intercept that I'm going to be looking at is at -3. And so, again, that's where I was expecting the confusion would be. I'm sure that a bunch of people who do this question always put -9 because they get conditioned really quickly to just look at the numerator and say, oh, yeah, it's the other one of that. I see +9, it must be -9, and it's a done deal. But then you're missing that key step. So by factoring the line into everything else, it allows you to get a quadratic on the top to factor and get that your x-intercept's actually -3. If you did a sign diagram with your x-intercept at -9, you would probably notice that the sign wouldn't change across -9. The tricky thing, though, oh, I didn't know Gyung was here too. Okay, so Jake and Gyung are here. So many people I didn't even realize were here. So the tricky thing with this question is across -3 as an x-intercept, it's also not going to change, oddly enough, because this factor here is squared. So what that means is before -3, it's going to be, well, let's actually see. What will it be? If I plug in 0, which is in this range, I say x equals 0, the whole thing's positive. So that means it's going to be positive there. It's still going to be positive here because it's not actually going to change signs. But across that -5, it is going to switch back to being a negative. And so you can plug in test values to verify that for yourself. I would probably use -4 there and maybe -6 here. No matter what I put into the numerator, it's always going to be positive. So really, you just have to focus on the denominator. If I plug in -6, I get -1 in the bottom, which means that part's going to be negative. If I plug in -4, I get +1 on the bottom, so the whole thing's going to be positive. So there's my sign diagram for that one. So if you ever have a function that's not as clear cut, or it's not in a form you're used to seeing it in, your best bet is to actually put it in a form you're used to seeing it in and go from there. Moving on to the other question that Michael requested, the graph of the function f of x equals -3x squared. And the domain goes from 0 to 2. Sketch the graph of y equals f inverse of x. So here we're just sketching the inverse. It says, it doesn't say to sketch it on the graph. So just full disclosure, if you are doing this question on the exam, whether it's an IB exam or one of my midterm exams or for DP2s on the mock exam, usually anytime they have you sketch an inverse or something with transformations, a lot of times it's on the same grid as the original one. That tends to be more true for inverses than for transformations. Sometimes the transformations get too big and wonky to fit on the same grid. And I think they don't want to telegraph too obviously how the transformation should fit by making the grid appropriately sized. I mean, I might just be speculating there, but that's the impression I get. Anyway, with this one, to sketch the graph of f inverse, I would need to draw just the mirror image of this across the line y equals x. So this point here that was at 1, -3 is going to move over to -3 and up to 1. I'm going to have that point there. And the other point's going to be at -12, so my scale is clearly not appropriate. But over there I'm going to have -12 and 2 as a point. And so it goes from the origin and it goes out through here. And this is why it's good to have a grid. I'm just going to move this point now. I'm going to cheat here. All right. So just swapping the points like that will allow you to graph it appropriately. Again, clearly the importance of a grid is pretty significant. It's one of the reasons why I don't like to assess those types of questions if there's no grid provided, because you can sketch something and it ends up looking as bad as those first two did. Oh boy. Okay. On to part B. Oh, which now, I can't remember. Michael may have only been concerned actually about one part of this. What did he say in the chat? Oh, just A. Okay, so Michael, do you not want to see the rest of this question then? Everything else was okay? Can you just confirm that in the chat while I kind of queue up the next question? So what was the next one here in the queue? Jack had requested practice paper 1, number 7B. All right, I'm going to go digging for practice paper 1 here. And it might bump out a OneNote for a second because for some reason, as I move to other windows, it decides it doesn't want to show that anymore. I think OneNote just gets lazy. Where is... Let's see, exam prep. Here we go. Practice papers. So Jack wants to do practice paper 1, number 7, he said. Practice paper 1, for some reason, it's taking forever to load. Here we go. Practice paper 1, number 7. So this is a DP1 question. And Jack, I'm looking at practice paper 1, and it's got 2 parts, so I'm not sure which one you want to do. I'm going to screenshot both and pop them into the OneNote, and you can weigh in. And hopefully Michael was paying attention so he could comment in the chat and say that he's satisfied with number 9 or he wants me to keep going. Okay, so Michael said yes, so we'll move on to the next one. So Jack, I have the question now in for number 7. If you want to weigh in and say if you wanted both of them done or just one of them done. This is actually an applicable question to both groups because, especially if it's B, as Jack just said. because b is solving a logarithmic equation with change of base. So that's kind of a fair game thing for anybody. That could very easily show up on both DP1 and DP2. Heck, I could use the same question on both papers. It wouldn't make a difference. I mean, you guys are writing at roughly the same time, so I guess there could be no swapping of information. Okay, so we have a logarithm here that we need to solve. One's base 2, one's base 4. So any... Yeah, okay, Jack. Thank you. I will try harder to make more challenging exponential equation questions for you. But for B, looking at those logarithms, as soon as I see two different bases, I know I have to use change of base. That should be like an instinctive reaction for you, because when you see them, you should know all your log laws only work if the bases are the same. If I see log base 2 and log base 4, I know they're incompatible. I gotta make one of these things change to be the other. And so, oh, come on, Ian. Don't be mean. Now, if Ian asks any questions, I'm just going to ignore him. He's blacklisted. So, if I use change of base here, it's in your formula booklet. Please make sure you reference it. Please, please, please. If you have logarithm base a of b, you can rewrite that as a ratio of any two logarithms with a base of your choosing. The argument of the top logarithm is the argument of your original one. The argument of the bottom one is the base of your original one. And it actually doesn't matter which one I change. And so, really, you pick. Like at the end of the day, I've done this question already with a few people in DP1. And in fact, there's one or two people who I challenge to just do it either way, to kind of see for themselves which way they found to be the easiest. But ultimately, it really doesn't matter. I usually suggest changing the larger base logarithm into the smaller base, but again, it's 6 of one, half a dozen of the other. It does not matter. With this first logarithm, even though I'm not changing the base here, I am going to bring that square root down in front. Because if there's one thing I always find with solving logarithmic equations, it's that having exponents on the argument is a royal pain. And so if there's a square root on something, I'm pulling that square root out and making it a coefficient, because it is much easier for me to deal with it as a coefficient than it is for me to deal with it as an exponent. And then for that second logarithm, I'm going to change it to base 2. So it's log base 2 of x plus 1 divided by log base 2 of 4. So you can see I've taken the two pieces of that logarithm and popped them into their appropriate spots in the equation. So the reason why this is helpful then is because log base 2 of 4 is actually very straightforward for me to evaluate. So I have that first term I'm not going to change on this next step. But if I evaluate log base 2 of 4, I get 2. And so this is essentially log base 2 of x plus 1 divided by 2, or another way of thinking of it would be multiplied by half. And so I hope at this point you can kind of see why this would be so convenient, because if I multiply everything by 2 here, it's going to tidy up quite nicely. So multiply every single term in this equation by 2. I get rid of the halves in each term with the logarithms. So I get log base 2 of x plus 7 plus log base 2 of x plus 1 is equal to 4 now. And now I'm actually in a position where I can use those log laws to combine logarithms. I can use the addition rule. I have two logarithms of the same base, so if I'm adding them together, I multiply the arguments. I'm going to get log base 2 of x plus 7 times x plus 1. That is equal to 4 still. And so I can expand that out in the brackets. Log base 2 of x squared plus 8x plus 7. And so then the trick here is once you have a logarithm equal to a number, that's when you rewrite it as an exponential. So again, in your formula book, you have this sort of, gosh, I don't even know what to call it. It's just like a primer for how to change something that looks like an exponential into something that looks like a logarithm. So it's just telling you how to swap between the two forms. Right now I have it as the form of a logarithm is equal to a number. I can change that to an exponential. So this is going to become 2 to the 4 is equal to x squared plus 8x plus 7. 2 to the 4 is 16. And so as I keep working through this, I get 0 is equal to x squared plus 8x. And moving the 16 over to the other side, I get minus 9. And so this quadratic factors pretty easily. I tried to make it, as best as I can, quadratics that will factor easily enough, because what I'm assessing you on in this question is not your quadratics factoring skills. That's a small piece, but I'm assessing you on your knowledge of logarithms. So if I make the quadratic at the end just brutal and you don't get the right answer, even though you did all the logarithmic stuff right, that to me is me missing the mark. So this factors nicely to be x plus 9 times x minus 1. So x is equal to negative 9, x is equal to 1. And if you stopped there, you would almost get the correct answer, and you would almost get full marks. But the problem is, if you just leave the answer at that, you have forgotten a key thing from way back up here at the top, which is to say that if I were to plug in negative 9, I have a serious problem, because negative 9 means I have to take the logarithm of a negative, which I cannot do. It's outside the domain of a logarithm. If I plug in negative 9 to either one, actually, if I plug it into the first one, log base 2 of root x plus 7, I have two problems, because first I try to square root a negative, and then I try to take the logarithm of the square root of a negative. It's a whole mess. So that one is outside the domain of the question. This one I'd have to reject, because ultimately I can't make the argument of a logarithm negative. So the only answer that actually works here is x plus 1. X equals positive 1. So that would be the answer to that problem. If you didn't reject the one answer, if you just left them both and you kept on going, you'd probably lose, not all the marks, but at least one. Okay, so that's the extent of that question. So I don't know if there are any questions, or someone wants me to go back to something. I see that Jack did ask how the 2 became a 4, but Michael clarified it. And if at any point you find that I'm going too fast, I'm pretty sure I toggled on YouTube the setting where this would go back. It said something like DVR. It allows you to rewind, so if you miss something, you can click back and rewatch it, and then press the button, I think, that says like rejoin live, and it'll catch you up. So I think Cam had a question next. So Cam, if you had tuned out while we were doing some DP1 questions, now's the time to tune back in. He asked for practice paper number 1. And then question 10. Oh, yeah, that's a good one. Good vectors and trig. That's a big one to screenshot, though, so just give me a second. Hopefully I can pull this over without breaking things too much. Oh, why did it screenshot so small? That better still be a good resolution when I expand it. Yeah, that'll do. I think I can zoom in and work with that. Okay. So before I jump into this one, just want to take a look here at what other questions have been asked. So I did the one that Jack asked. So Jake's got one that he's requested. Anna requested another one from past paper 1. Okay, some of your reactions make me wonder if you guys ever actually have used YouTube before. All right, I'm glad to see everyone's in high spirits on their snow day. By the way, just as some housekeeping items for anyone who showed up a little bit late to the party, because now I see there are 10 people watching, and I'm starting to lose track of who's here, or who's checked in at least. And the DP1s seem to be flooding the chat with silliness, and the DP2s are remaining relatively quiet. Um, so things that I covered off the top. Thanks, Jack. So first thing, the stream is on a bit of a delay. I don't even think that was something that I had control over. I'm pretty sure it does that automatically. That there's like a 5 or 10 second delay. So if you're noticing this like weird lag between you guys saying stuff in the chat and me saying stuff in the stream, that's the only reason why. So for example, I'm only now just seeing James's comment saying hello, hi James. But by the time you're hearing it, he's gonna have been in the chat for a few seconds. So that was housekeeping piece number one. The other thing I said is I just apologized up front for any like ambient noise. You're probably hearing my desk chair squeaking a lot because it's an old, crummy desk chair, and so it squeaks like crazy. Um, and I'm also in the basement of my house, so you may occasionally hear the furnace rev up. And there has been at least one issue during the stream with a cat getting into shenanigans and needing to be stopped. And I'm sure that won't be the last because one of them keeps trying to get in behind the desk to chew on electrical cables. I swear cats are not intelligent animals, and I'm sorry to any of the cat people who are here with us right now. Um, oh gosh, she'd gone away and now she's back. Get out of here. Uh, what else? What else? Oh yeah. So if you have questions, just post them into the chat section of the textbook, page number, question number, or if it's from a past paper, then just mention which of the past papers. And please make sure you are clarifying that, like, just make sure you write paper 1 or 2. So don't just say past paper question 3, because then I won't know which one you're talking about. Can I do, so Jake's asking, can I do all of this question? All of the one that Cam requested, you mean? Or all of the one that you asked for? I'm not clear. I'm going to start this one, and Jake, you can clarify in the chat. Any DP1s right now, you guys can busy yourself with working on stuff, because we're in vectors territory and trig territory, which is well outside of your purview. James, no, vectors are not on the DP1 exam. I just have both DP1s and DP2. Yeah, James, please don't start freaking out thinking that you didn't study a significant portion. If it's not something I taught you, you shouldn't expect to be assessed on it. Yeah, basically the only people I expect to be paying attention right now should be Anna, Sophia, Jake, and Young, who I think are the only DP2s here. Although we now have 11 people, so there's somebody new who's watching. All right. Oh, and Cam. I didn't mention Cam. And this is Cam's question. What am I thinking? Sorry, Cam. All right, but here we go. I have 2 position vectors. So these are vectors that are pointing me to points that are somewhere in, well, 3 space based on the fact that they're 3-dimensional vectors. And so vector OA is a vector going from the origin to a point A. And I'm not going to try and draw a diagram here because it's 3D and that's just going to be a mess. So you're just going to have to imagine it in your mind. So if you've got the origin, this position vector OA is telling you that there is a point sort of in that direction from the origin, negative 1, 0, 4. And OB is giving you the directions to a point B. And so they're saying find the vector from A to B. And so basically, the one thing that you have to remember about position vectors is that they are basically the coordinates of a point. Like if you consider the vector between 2 points, which this is something I can't actually remember if it's in your formula booklet, oddly enough. Normally I'm pretty good at remembering what's there, but I honestly, even though I encourage you guys to look at it all the time, I actually consult it very little. I'm sorry to say. And so sometimes I forget what's there. It's also all this stuff with curriculum revision that's kind of crossing my wires in terms of what needs to be known and what's given. Anyway, so the vector between these 2 points, if it's a vector OA, that means it's just going from the origin to where A is. And so if you consider A to be the second of the 2 points, then what's happening here is I would basically be taking -1, 0, 4 and subtracting the coordinates of that first point at the origin, which would be 0, 0, 0, which is why the vector is just -1, 0, 4. So the coordinates for the point itself are the components of that position vector. So what that means is basically if I want to find the vector from A to B here, I just have to notice that the coordinates of B are 4, 1, 3. Coordinates of A are -1, 0, and 4. So this works out to be 5, 1, -1. And so once I have that vector, I just now have to get the magnitude of it, and then I'm all set. So magnitude of a vector is just found by doing like the square root of each of the components squared. So the magnitude of AB is the square root of 5 squared plus 1 squared plus -1 squared. And, oh gosh, Jack. Okay. I feel like I'm going to have to mute you in the chat. You're being so ridiculous. Anyway, so this works out to be what? 25 plus 1 plus 1. So root 27 is the magnitude. So that's the end of part A. Any questions about that so far? Or are we good with part A of this question, DP2s? Cam especially, since this was his request. Just want to make sure that we're good so far and we're ready to move on. This is also an interesting test of the delay. I'm pretty sure it's actually like closer to 30 seconds now, which is a little silly. And Cam's not reacting. I hope he's still here, that he hasn't disappeared. Anyway, I guess I'll just keep moving along. So oh, there we go. Thumbs up. Thank you. So on to part B. So it says the point C is positioned such that AC has the vector -1, 1, -1. And it says show that the coordinates of C are -2, 1, and 3. Believe it or not, this is still using that same idea from the previous question. If I'm looking for the vector AC, I find it by taking the coordinates of C and subtracting the coordinates of A. Now, I don't know the coordinates of C. That's what I'm trying to solve for. But I do know the vector AC, and I do know the coordinates of A. So the vector AC, which I'll put on the left side, is -1, 1, -1. And so I know that that's equal to C1, C2, and C3, subtracting the coordinates of A, which we were given right at the start. It's -1, 0, and 4. So this basically just gives me really simple linear equations to solve. Because if I look at them separately, right? So focus line by line. I know with vectors it's always a little clunky because you look at it and you think, oh, there's so much stuff going on. But realistically, when you focus line by line, this is what we're looking at. That -1 is equal to C1 minus -1. So basically, in order for that to be true, C1 has to equal -2. And if I keep going along from this line, I know that C2 is equal to 1, and C3 would be equal to 3. And I'm thankful that those are the answers, because that matches up with what I was asked to show that they were. And so I would be pretty worried if it didn't turn out that way. That would mean that somewhere along the line I've done something wrong. But the fact that it matches up, that's a good sign. Okay, so that's part B. Now, A and B, I think, are the simpler parts. These are those questions in the part B of an exam that I've said before. I really feel like everyone should be doing fairly well on those parts. Like I think I've said before in our exam prep with the DP2s, when you look at the makeup of the exam, you've got part A, which is 1 to 7, part B, 8 to 10. Everybody should be fine with the first 5 questions in part A. 6 and 7 might be a little bit tougher. And then when you get into part B, realistically, everyone should have a decent shot at 8, and then, 9 might be a little bit more challenging, and then 10, maybe you only do the first half of the question, maybe a little bit more, and then it starts to get challenging. And so here, we're kind of right at that precipice of where the question starts to go from fairly approachable to way out there. And that happens not during part C, but kind of after part C. And so if things start to fall apart there, it's completely understandable at that state because of how the complexity of the question just ramps up. It dials up from very little to quite a lot. Anyway, so in this question, I'm looking, the following diagram shows triangle ABC. We're letting D be a point on BC, and the acute angle ADC is theta, and that's all labeled here. So while the diagram may not be to scale, everything that's mentioned in that sentence is indicated on this diagram, and it's all thankfully placed appropriately. So then they say write down an expression in terms of theta for angle ADB and area of the triangle ABD. So if you think about what they're asking you in C part 1, they're asking you for this angle here. This is the angle ADB. Now, once you realize what angle they're asking you for, that part should become fairly straightforward because it's supplementary with theta. So, I don't think that the IB would particularly care which way you write it out here. So if you're working in degrees, you would be writing 180 degrees minus theta, and that's fine. If you're working in radians, you might write pi minus theta, which is also fine. I don't think they would care either way. I don't know what I put in the solutions for this that I posted, but I'm pretty sure I didn't mark any differently for that either. I'm not sure if I can pull that up. Anyway, while I'm looking at that, the area is more or less straightforward to do as well, because we know some of the distances here, or at least can work towards figuring them out. So, the area of triangle ABD, this is going to rely on using the trig definition of area of a triangle as opposed to the 1/2 base times height thing. So triangle ABD here, the angle that I'm likely going to be focusing on will be this guy right here. And so, what just happened to my video there for a second? That's alarming. Hope everything's still okay. If the audio cut out, hopefully someone will speak up and say something. Technical difficulties is what happens when you don't have like a production team on staff. Gosh, my cough is getting really bad. Okay, so as I was saying, the area of triangle ABD, we're going to use the equation area is equal to 1/2 AB sine theta. It's in your formula booklets. You do not have to know that from memory. It is freely there for you to reference. So basically what the expectation is here is you're actually going to write out 1/2 times the magnitude of AD times the magnitude of BD times sine of the angle that's between those two sides. So the two sides I've just referenced are this one, which is AD, and this one, which is BD. And so the angle that's between them is the one that they just asked you to express in terms of theta. So pi minus theta. So that's all you have to do to write down an expression in terms of theta. You don't actually need the values for AD or BD. In theory, eventually there will be a way to find those, and then you can come back and find the area, but at no point in the question is that actually asked for. So when I look ahead, I see something about ratios happening, and then hence or otherwise find the coordinates of point D. So we only find the coordinates of point D as the last stage of this question. And so oh, that's interesting. Sorry, I'm noticing the stream health has gotten worse. Sorry, I'm just trying to troubleshoot to figure out what's going on here, because according to YouTube, it's saying that it's streaming really slow. I'm not sure why. Yeah, don't worry, Jake. I'm gonna backpedal on that explanation in a second, just to go over it. I just want to make sure that everything's running smoothly for people. YouTube is still telling me that it's running slowly, and so I just want to make sure that it's not going to die. I'd hate to be sitting here and talking through a question and find out that no one was actually listening. Yeah, it's still saying that there's issues with video output. I just refreshed to see if it made a difference. If you are noticing issues, please do let me know. I'm not sure what happened when the screen flickered, but things seem to have gotten worse at that point. But we'll keep soldiering on. Might be an issue just with my Wi-Fi, because I'm doing this on the Surface. I'm not plugged into the internet. But we'll keep working at it. Anyway. Back to finding the area. Okay, so admittedly there were a number of pauses and stops and starts in the middle of that explanation. And I may need to take a break in a second to go get more water because my throat is just killing me. And I don't like coughing in your ears constantly. But the area of the triangle, the equation that we use is 1/2 times AB times sine of the angle in between them. So what that means is I basically need to know two side lengths and the angle that's contained between them if I'm going to find the area of a triangle that way. So that side and that side would be the main ones that I'm looking at here. And the angle in between using this equation here. So I don't actually know the lengths of those sides yet. I don't have them numerically. And realistically, there's no way for me to find them numerically at this point. But I can just represent them as their magnitudes. So I know that the length of AD is just the magnitude of AD. That's what I wrote here, because it's one of the easiest ways to refer to them. The other side of that triangle that I'm looking at is length BD. And so I can use the magnitude of BD as the other side length of the triangle. So that's where the product is happening. that product AB in lowercase from the equation, these guys, that's what this part is. And then sine of the angle between them. In the previous step, I was asked to find that angle ADB, which is the angle in between the two sides that I was just talking about. So previously we said it was pi minus theta or 180 minus theta. So that's the angle that I'm going to sub in there as the angle between the two sides. So I'm just taking what's in the diagram. Now, I don't need those magnitudes. I don't need to know anything about them realistically, and you'll see why in the next question, why it's okay that I can just express the area that way. And I know it's really general, which is probably why Jake said, and I quote, "I'm tripping right now." But having said that, like it is still, it is still a valid equation for the area. So Jake, I don't know if that clarified anything for you, or if you're still feeling lost about that. And of course, because we're on a delay, I have to wait a little while before you even hear my question to respond to it. Hmm. No one's weighing in. What's going on? Oh, okay. Perfect. All right. So if you're good to go, then we can keep moving on to the area part. So I think this is the part of the question. That's the threshold where people are going to get lost. Um, yeah, this is the part of the question where I think everyone would normally be good, probably up to C, or at the very least C part 1. As soon as you hit D, things get a little bit wonkier. And I'll show you why. In fact, as we start to work through it, you'll probably realize where the stumbling block is pretty quick. So they say, given that the ratio of the area of triangle ABD to the area of triangle ACD is equal to 3, show that the ratio of BD to BC is 3 to 4. So that seems straightforward enough, right? They're giving you two ratios, so you're thinking, okay, fine, I'll just plug some stuff in and we'll see where we get. So from that leftmost ratio that they gave us, I know that the area of triangle, I'm just going to rewrite it, area of triangle ABD divided by the area of triangle ACD is equal to 3. So what that means is that, and I think, there we go, the ratio of this triangle's area to the area of this one is 3. Basically, what they're saying is that this one here, which I've just labeled with a 1, is 3 times larger than this one that I just labeled with a 2. So that becomes really helpful because if I can come up with equations for the area for each of those, I should be able to relate them. I've already figured out the area of 1, right? It's what we started with in the previous question. We had 1/2 AD times BD times sine of pi minus theta. That is the area of triangle ABD. So I didn't even have to do any work on this question, on this step, I mean, to find that information. So I'm just going to write this in here. And I'm going to need to divide that by the area of the other triangle. Now, this one will technically require some new work, some new thinking here, but it's basically the same premise as that other area equation. I'm still going to use 1/2 AB sine C, but I'm looking at this triangle that I labeled with a 2. And so let me just remove the labels there for a second on the sides so I can see it a bit more clearly. I do know an angle in that triangle. I know this one right here is theta. And so that means that I can set up the equation for the area of the triangle by doing 1/2 times the length of AD times the length of DC times sine of the angle between them, which is theta. Yeah, so there are a few things that are going to divide out here. If we were in class, I'd be asking for input on what you think is going to divide out. But if we do that in this venue, this is going to take forever. So I'm just going to point it out. The halves are the first thing to go. 1/2 divided by 1/2, it's toast. Also, the length of AD, it's the same for both, so it's going to divide out too. Now, there's one other thing that's going to get the axe here, and it's not the lengths of BD and DC. While BD and DC do make up the same line from B to C, that doesn't mean I can just divide them out. However, sine theta and sine pi minus theta are actually equal. That is basically, if you think about the unit circle, right? That's saying if I was over here, I'm going to have the same y value as this one. Or for that matter, if I had an angle here, it's going to have the same y value as this one. So they actually work out to be the same. Think about even the sine function, if you will. Sine theta looks just like this, right? Starts at the baseline and goes up and down. What this is saying is that sine of an angle will be the same as pi minus that angle. And so it's basically, if this is pi, sine of the angle here would be the same as over here. And here would be the same as over here. It's just establishing that symmetry in sort of the first bump of the sine function. Technically, this is an identity. It's just not one that's in your formula booklet. We don't really, like I taught it to you last year in DP1. It's not something that's really emphasized or used a lot. I think its official name is like a co-function identity or something. Jake, as someone who's done more trig than the other DP2s, you've maybe seen that one or had to memorize that one at some point. But it is important to know that those ones are equal. Not for every question, mind you, but for this question. That insight is what makes this a more challenging problem. And so those two being the same thing, they actually divide out. And so what we get is that, oh gosh, what's left over here? 3 is equal to the length of BD divided by the length of DC. Now, if you think you're done, sadly we're not. Because what we were very clearly asked to do is show that the ratio of BD to BC is 3 to 4. And we have not done that yet. In fact, what we have shown is that whatever length BD is, it's 3 times as long as DC. So that's not that's not the final step of this question, but it's like we're basically there. There's not too much further to go. Of those, what's it out of 5 marks? Of those 5 marks, you've probably earned 4 of them at this point. The final step is to recognize something that I mentioned earlier, which is that BD and DC are along the same line. So BD and DC, if you add them together, is equal to BC. So BD plus DC is equal to BC. Not a huge intuitive leap, but if it's not something you knew you were looking for, it's very easy to miss. I think that's probably the bigger hurdle. And so what that means is if you spot it, great. And if you don't, you could conceivably sit there scratching your head for quite a while being like, what the heck do I do next? But once you see that piece, once you look at the diagram and you see, all right, BD plus DC is equal to BC, I get it. Then what you can realize is, okay, I know that BD is equal to 3 DCs. And I can combine those two equations and say, okay, so 3DC plus DC is equal to BC. So 4 DC is equal to BC. So now I have a ratio there, don't I? That BC is equal to 4 DCs, BD is equal to 3. So that means if I take BD and divide it by BC, that's the same as 3 times DC divided by 4 times DC. The DCs cancel. And so now I've proven the ratio that they asked me to prove, that BD divided by BC is 3 over 4. And so I'm done that one now. So I think now that that question, or sorry, that part of that question is done, you can kind of see why that one is the cutoff point, I think, where some people will get stuck and some people will keep going. Thanks, James, for requesting another question there. I notice DP1s have thrown in a few questions into the mix, so I will switch back to you guys in a second. The DP2 questions are decidedly more involved than the DP1 questions. Feels like for every one DP2 question I do, I can do 3 DP1 questions in the same amount of time. Which just goes to show DP2s how much you've learned over the past year and a half. Anyway, are we good up to this point? I just want to clarify that before I move on, because I'd hate to start part E and have anyone lost here. So any DP2s who are still here, because our numbers keep fluctuating, so I'm not sure who's still around. Are we good? Anna says yes. Or sorry, Sophie Anna says yes. Cam, are you okay? And Jake? Okay. I'm going to hope that Cam's good. He'll probably weigh in any second now. On to the last one. At this point, I'm so far from the question, I've lost sight of what it is. Hence or otherwise, find the coordinates of point D. Okay. There are a few ways that you can do this. Quite a number of ways, actually. By knowing that this ratio is 3/4, that BD divided by BC is 3 over 4, what we technically know is that D as a point is 3/4 of the way down that line, BC. So one strategy that I've seen used by some individuals, you have the coordinates of B and you have the coordinates of C, right? We know that B from earlier on was, oh shoot, now I forget it. It was just there. 413. We know that B is 413, and we also know that C is, I want to say 21 something. Negative 213. I was close. So we know that those 2 points are there. So I can figure out the vector BC by basically just taking those coordinates and subtracting them. Negative 213, that's the coordinates of C. I'm going to subtract the coordinates of B, 413, which is just going to get me, it's interesting, negative 600. I obviously don't remember this question as well as I thought. Oh, and no worries, Cam. I'm glad that you're good. So I didn't remember that this question worked out to have that vector be negative 600. That's actually pretty darn convenient. Because if I know then that the point D is 3/4 of the way along BC, I can legitimately just take BC and use it as a direction vector in the equation of a line. So if I say that I'm going to find the equation of a line And I'm going to say my starting position is at B, 4, 1, 3. And I'm going to add 3/4 of the vector BC. That's going to get me to the position of D. And so if me just writing that out is maybe not the best sell on that idea, let's go back up to this diagram for a second. I'm just going to clear out some of this clutter so I can draw on this without having a bunch of other competing diagrams. Basically what I'm saying is if I take that position vector to get me to here, and then I know the direction vector from here to here, but if I only go 3/4 of the way, right? So this would be 3/4 of the way along, whereas this one would be a full length BC. That's going to get me to my point D. That's essentially what I'm doing. So that vector for B at the start is basically taking me from the origin way over here, and it's saying, okay, get to the right starting point, and then add 3/4 of BC to get to where D is. So that's one strategy to use, and I think probably the more effective one of the bunch. Just as the math is going to be fairly simple on this, I'm going to have the vector 4, 1, 3 plus 3/4 of negative 6, 0, 0. So that works out to be negative 4.500 that I'm going to be adding into the mix. So it ends up being negative 1/2, 1, and 3 are the coordinates of D. So I'll write that vector as OD, and that would be it. Jake's asking, wait, why did we use 4, 1, 3? So 4, 1, 3 is the position vector for B. Could I use A? Yeah, using A wouldn't work. So I used 4, 1, 3. It's the position vector for this. 4, 1, 3 is what gets me to that point. And then I'm adding the vector to move along that line to get to D. So I'm not using it for A, I'm using it for the point B, because that's what's on the left end of this side of the triangle. So here's point B. And that's why I needed to start with those coordinates and then move along the line BC to get there. I don't know if that makes sense or no. Jake, just let me know if I'm way off base there. While Jake is mulling that over, I'm just going to look at some of these DP1 requests and see what people were saying. So Anna's asked a past paper question. Jake has a question too. I'm pretty sure I did Jack's question. Where's the next DP1 question? Practice paper 2, number 2. Okay, let's dig up that one. Gotta find where they are. Where did I put those? When the stream messed up a little while ago, it jumbled my windows, and now I need to figure out where everything went. Okay, I'm opening paper 2. It's just not loading for me. That's weird. I should have a little... just hold on for 1 second, everybody. This PDF's loading up, but while it's doing that, I'm just going to quickly grab a little pad of paper so I can jot down what questions you guys are asking. Because scrolling back through the chat is getting to be very tedious, so just give me 1 sec. Okay. So, okay, why is paper 2 still not open? This is so weird. Oh, finally. Okay. So, going through the chat here just to see what people have requested. There was one that Anna had. So, make a list of DP2 questions and DP1 questions. Anna said past paper 1, 3B, part 2 specifically. Okay, that sounds like one I should be able to do really quick, so maybe I'll do that one before I start into the DP1 stuff. Jack said past paper 2. Number 4. James has asked for past paper 2, number 2, and number 4, so that's another vote for that same one Jack asked about. Michael asked for one that I can't find. Oh, paper 2, number 2. Okay, so apparently it's just those 2 questions that the DP1s want to see, and now one for DP2. Okay, I'm going to quickly jump to that one that Anna requested, or that Sophia requested. Sophiana requested it. Because it looks, just based on what she's asking for, paper 1, 3B, part 2, I feel like that must be really quick. Unless I made a really skewed exam here and gave a really difficult part to one question. I don't remember at this point. I've done so many exams. They're all blurring together. Okay. So, wait. Oh, I opened the wrong paper. Huh. Sample mock exam. Paper 1, you said. I opened up paper 2 by accident. And when I scrolled to the question that Anna was asking about, it was a calculus question, and I thought, there's no way we're doing that. That doesn't make sense. But I have found the correct question now, so here we go. And of course, it pastes in super small. So this is the question that Anna was asking about. And oh, okay. Yeah, this one is quick. Okay, see you again. Anyway, there are 10 items in a data set. The sum of the items is 60. Find the mean. So you've already done that part, I'm assuming. The sum of the items is 60 and there's 10. You're just doing 60 over 10 to get the mean. So it's 6. The variance of the data set is 3. Each value in the data set is multiplied by 4. So they say write down the value of the new mean. If every value has been multiplied by 4, then that means that the new mean, which I'll just label, I guess, as mean 2, it also gets multiplied by 4. So that would be 24. My understanding is you've already done all of that. I was just going through it for anybody else who might not have made it that far into the question. Admittedly, part 2 of question B is the harder part because variance is a tricky thing to keep track of when you change the values. And we talked a little bit about this in class. While we were reviewing for the exam. But it doesn't necessarily mean that it has become crystal clear to anybody. So the tricky thing is variance, we have to remember, is our standard deviation squared. And so our standard deviation is a reflection of how far things are separated around the mean. So if this is the mean, standard deviation is basically telling us how spread out stuff is in either direction. So we've got standard deviation that way and that way is going to basically be telling us how spread out the data is. We're either looking at data with a large standard deviation that could be really spread out, or with a small standard deviation that isn't spread out at all. I referred to it as a difference between stuff that's variable and stuff that is consistent. So in this instance, the one thing you have to keep in mind is when you add to a data set, it does not change the standard deviation. Everything just shifts. So if let's picture, just for the sake of simplicity, let's picture it as if this was normally distributed. So it's normally distributed like this, and there's the mean, and the data's I don't know, got a standard deviation of whatever. If I add something to every data point, it's just going to shift over here. It's not going to change shape. Oh, bye, Cam. It's not going to change shape. It's not going to do anything like that. It's just going to move. If you change the standard deviation, what's actually going to happen is it's going to spread out more if you're making the standard deviation bigger, or it's going to get smaller or narrower. The standard deviation gets smaller. Now, that standard deviation only changes, though, if you're multiplying by something. When you multiply the data set by a certain value, you're actually spreading out the data more. It's essentially the same as a horizontal stretch. So anytime, like if I had a bunch of data values, just very generally, let's just say it's a small data set of only 4. If I multiply everything by 3, that's going to change the mean, as we saw in part 1, because everything was tripled. So when I add them all up, the sum of all the values is tripled, which means when I divide it by however many there are, the result's still tripled. The same is also true for the standard deviation, because if I look then at how my mean is 3 times bigger, and I'm taking away an x value that's 3 times bigger, and doing that repeatedly to get the standard deviation, then the standard deviation is going to change in very much the same way. It's just going to result in sort of a multiplication by 3. The reason why it works out to be exactly multiplication by 3 is due to the equation for standard deviation, which, correct me if I'm wrong, I don't think that's in your formula booklet. Hold on, let me pull that up for a sec. Even if it's not in your formula booklet, I'm just going to screenshot it from somewhere. Where would it be? I can probably grab it from your textbook. Page, I want to say 500 or something. How close that would mean. Aha, there we are. Okay, so screenshot this. I'm going to pop that in here. Okay, so this is the equation for standard deviation. Now, I don't necessarily expect you to know this. Memorizing it is not necessary to solve this question, because the shortcut to the Jake's saying, shouldn't we multiply our new x values by 4, not 3? Oh, sorry, the numbers that I'm picking aren't relative to the question. I was just picking values at random. But sorry, you're right. If I was being consistent with the question, those would have been 4s. That's my bad. In fact, I'll use 4 from here on out just to avoid confusing the issue. Anyway, so knowing that this is the equation for standard deviation, if I multiply all my values by 4 and my mean gets multiplied by 4, it's basically like I've squished in a 4 here, right? And I've squished in a 4 here. Because each value is multiplied by a 4, and the mean is also multiplied by a 4. Now, I always have someone inevitably say, well, wait a minute, the standard deviation is the square root of variance, so why does it come out that it's 4 times bigger or something? It's they think that the square root has some sort of effect, but you have to remember when we found the standard deviation originally, way back in DP1, we were finding the variances. We were finding the deviations, which is just taking the values and subtracting the mean. We were finding those deviations and we were squaring them. So actually, if you were to just look at the sum of those deviations, because those values inside the brackets have been multiplied by 4, the final result is actually multiplied by 16, right? And so I have 16 times the sum of all those deviations over n. And that's what's under the square root when I'm calculating standard deviation. And so when I square root the 16, I just get back to 4 times the original standard deviation. So what that does then is if I had my old standard deviation, so let's say the old one was, and I'm going to use sigma. The old one was sigma, then the new one, if all the values were multiplied by 4, is going to be 4 times sigma. So the old one was sigma, the new one is 4 times sigma. Now, that's not what the question was asking, though. It wasn't asking you what's the new standard deviation. It was asking you about the variance. And I think this is why this question is a tough one. Because most people have probably had discussions in class about what happens to the standard deviation. In fact, I think that's all we've done, if I'm being perfectly honest. We've only discussed how if you add something to the data, standard deviation doesn't change. If you multiply to the data, standard deviation does change, and it changes based on whatever you multiplied by. We don't talk about the variance. The reason we don't talk about the variance is because we hardly ever use the variance. This is kind of a cheeky question just to see if you're paying attention and if you know what's what. And so the reality is, if your old standard deviation is sigma, your old variance is sigma squared. And so if your new standard deviation is 4 times sigma, then guess what? Your new variance is 4 times sigma squared, or 16 times your old variance. And so that's the trick to this question, is understanding that multiplicative factor is actually 16 and not 4. And so if your old variance was 3, as it is in this question, then your new variance will be 16 times 3, which will be 48. And so that's the answer to practice paper 1, question 3b, part 2. Maybe not as quick as I thought it was going to be, all things considered, but understanding the quirks of standard deviation and variance is tricky. And this type of question does seem to show up a lot on IB exams. I can't remember off the top of my head if it's on your mock exam. I wish I could, but I think I mentioned to a few of you that I made your mock exam back at Christmas time, and so honestly, someone could show it to me and I'd be like, is that the mock exam? Maybe. I wouldn't know. It's that far out of sight, out of mind. But anyway, usually if this is ever on an exam, it's only for like a mark or two. So if you are still struggling to understand it, I mean, devote a little bit of time to trying to figure it out. But if it doesn't click, and this would benefit from us like sitting down and looking at a concrete example with data, so you could actually process what's going on, because this was very general and algebraic. If you need a more concrete example, then I wouldn't sweat it, because the reality is, even if you didn't know it and you went to the exam being completely oblivious, you're only going to lose a mark or two, realistically. So to that end, if I'm weighing like time I should spend on it versus how much it's going to cost me if I don't, I wouldn't lose sleep over it. All right, anyway, so that would be the end of that question, and I think that's the end of my DP2 requests. By my count, I still have Jake, Anna, and Sophia here. If you guys have more questions, queue them up, but I'm going to switch gears to tackling those DP1 questions. So DP1s, if you are here and you have just been idly listening while you work or waiting for a time to come back, now is the time. I'm going to screenshot those questions from practice paper 2 that James, Michael, and Jack had been asking about, and we're going to tackle those next. Paper 2, and let's see. James asked for number 2, and so did Michael. So we'll pop that one in. And number 4, right? Oh, both sequences and series questions. Interesting. Okay. Well, I can do that. James, did you just post the same message again of which ones you wanted to see done? I made a list. I know what you're looking for. Just out of curiosity, who's still here? So I see 7 people watching. I know Gyung and Cam checked out. They went to work on other stuff. So who's still sticking around? James is clearly still here. I really wish there was a way that I could actually see. I don't know if there is. Again, this is the first time I've ever done something like this, so honestly, there probably is a window somewhere where I can be like, hey, who's here? And it would tell me. But I don't see it. Okay, Mike's still here. All right, Anna Sophia, good luck studying for chem. Jake, quick question. If I'm trying to find the point of intersection of 2 functions, I can graph them on my calculator. Yeah. If it's on the calculator paper, sure. That's fine. Otherwise, you'd have to set them equal and algebraically solve it. However, Jake, I will say this. If there are 2 functions that are different from each other, so like a logarithm and an exponential, or a logarithm and a quadratic, then you'd have to do that on a calculator. And there's no way I'm going to give that to you on a paper 1, I promise. The IB wouldn't either. Because at the end of the IB exams, I get to write a sheet saying whether I felt the questions were appropriate. And you can bet I would tear a strip off of them if they gave you a paper 1 question that was like, solve this equation, logarithm equals exponential plus rational or something. I would have words for them, I promise. So yeah, points of intersection, completely fair game. If you're on a paper 2, use your calculator. There's no reason you shouldn't. And Emily Tam is here. Emily, how long have you been here? I didn't even know you were watching. Yes, Jake. If one's exponential and one's linear, 100% do that on your calculator. Don't even give it a second thought. All right, let's take a look at these sequences and series questions. Jake, you can feel free to stick around and listen in on this too, because sequences and series are on your exam. Or if you've got to take off and study something else, like everybody else, switching gears to chem for DP2, I would completely understand. Anyway, oh really? You've been here that long? Is this the first time you said something in chat, Emily? My goodness. I had no idea you were here. I was wondering how our numbers had gotten up to 11 at one point, and I could have sworn that there were only 7 people or so who had checked in. Anyway, we have one of these is arithmetic and the other one's geometric. That's actually perfect because, well, I mean, this way we get to practice both. So we'll do number 2 first, which should make Michael and James happy. Sorry, Jack, you'll just have to hang on for a minute until we get to number 4. Although this one's worth paying attention to as well. Thank you, Jake. Your loyalty is noted and appreciated. I'll be sure to send an email to Miss George. I'll screenshot your comment there. Although with your name, she won't actually know it's you. So, question number 2 from practice paper 2. Sum of the first 5 terms of an arithmetic series is 85, and the sum of the first 6 terms is 123. So, when we're talking about sums of the terms in a sequence, or sum of the terms in a series, uh, the notation we use instead of U, which is for the terms, we use S, which is for the sums. Um, I think S as a notation makes more sense because S for sum I think is very intuitive. U for terms, on the other hand, that doesn't make a whole lot of sense. So S5 is equal to 85. That's the sum of the first 5 terms. And the sum of the first 6 terms is 123. So this is the only information that's given to me. And I am asked to find U1, U2, and U3. And so this question might look tough because you're thinking that's a big leap. That's what's the end game here? How do I get from this to that? And there's a few different ways, if I'm being perfectly honest. And I think I've helped a few people with this question already. So the solution you may have seen, and maybe you just want a little bit more clarity on it. But basically, what I would recommend is when you're doing sequences and series questions, you have to look at what they give you and try and work with the equations that value connects to. Because the only other way to proceed is you just kind of grasp at straws and try and put the information into random equations where it doesn't actually work, or you try to guess at things, and inevitably you're going to end up on the wrong path. So if I know that the sum of the first 5 terms is 85, I'm going to connect that to the sum of the terms in an arithmetic series equation, which is in your formula book, it's n over 2 times 2u1 plus n minus 1 times d. Right? So it's in there. I think it's labeled sum of the first n terms of an arithmetic series or sum of a finite arithmetic series. If you have your formula booklet nearby, which you should if you're studying for your exams, then I would just go take a look, see what it's called. Just make sure you know where it is. Because on the exam itself, the formula sheet that the DP1s get is literally just I screenshotted from the formula book. I think I made the formulas a little bit bigger because there's fewer on the page, so I was able to squeeze more in. And I just set it up that way. So I gave you guys the stuff that you need, and you should be more or less set up to go. It's on a yellow sheet of paper, very vibrant. You won't lose sight of it during the exams. But you need to know where things are on it. Anyway, using that formula, I know that S5 would be equal to 5 over 2 times 2u1 plus 5 minus 1 times d. Could I please speak a bit louder? Ian, can't you turn your volume up? According to my microphone levels, I'm getting dangerously close to the territory where it would, like, blow your eardrums out. Anyway, I did just turn up the gain on my microphone, and so you should be able to see that there is a noticeable difference now in the volume of my voice. I apologize for anyone who's listening with headphones, and I've now just crippled you. Yes, Michael, the formula will be labeled. So here, let me get the formula booklet. Or actually, better yet, hang on. Let me just pull up the document that is your formula sheet. Before you get too excited, no, I'm not going to be showing you. I'm not going to show you the exam right now, but here, I'll move on to the screen. Oh, James, maybe your speakers aren't very good. There, I've turned up the gain on my microphone to full on the actual hardware. And if I go into my audio settings here, I can probably turn it up a little bit more. But I really don't want to go overboard. Anyway, so this is the formula page that you guys will get on the exam. Seriously, Jake. What a lucrative business. Um, so this is the actual document. This is what I sent to Miss Bosomworth to make copies of. Or no, actually, I made copies for her. So this is exactly what it looks like. And so this stuff I included just because like I really wouldn't want anyone to suffer on an exam because they, in a state of panic, forgot the area of a circle or the circumference of a circle or something ridiculous like that. Um, yeah, and then so these things are included too. 1.3, even though it's there, you do not actually need because we haven't done binomial expansions. But everything else will be useful to you. It's got discriminant and everything, so hopefully that works out. Um, yeah, James, you say the volume is perfect now until I, at one point, can't catch myself coughing and move away from my mic in time, and I blow out your eardrums with a cough. So that's the formula book. It's all labeled. You should be all set. I'm going to move that back off the screen now so that you guys aren't looking at that. And we'll go back to doing this question. So I was plugging in n equals 5 into this equation because that theoretically is the best way to go about solving this. If I simplify this a little bit, and mind you, it can't simplify too much, I get this is equal to 85. And that gives me one equation to work with. I don't know what Michael's laughing at. S6, on the other hand, would be 6 over 2 times 2u1 plus 6 minus 1 times d. So that would be 3 times 2u1 plus 5d. And I can set it up this way. Oh, I just realized I didn't even see Ian's question there. Sorry about that, Ian. Couldn't you use the other formula? I am not sure what you mean. Which other formula are you thinking about? I'm not sure if Ian actually was there to hear the question or not. um, okay, so Ian asked something about using another formula. I'm not sure which one he is talking about, so that's okay. We'll just keep working. Oh, this formula you're using it equals to something else. Hmm. The other one where it's all over 2. It's all over 2. Yeah, I'm not sure which one you mean. Oh, the first one plus the last one? Is that what you mean? Because I could use the other form of this equation. I'm just going out on a limb here and assuming this is what you guys mean. Because the other way of doing the sum of the first n terms is this way. And so technically, I could set up the question doing that. I could say S5 is equal to 5 over 2 times U1 plus U5. And S6 is equal to 6 over 2 times U1 plus U6. I don't know that that one's going to pan out as easily. We can do that one in a second too. Actually, let me just work through this for a sec. Um, does that work out? I think there's still too many unknowns because I don't know U5, I don't know U6. And so I don't know that that works out as easily. I do know technically that if I subtract these two, I'll get U6. And so to that end, I could say that 3 times U1 plus U6 minus 5 over 2 U1 plus U5 is equal to U6. But does that actually help me? 3U1, 3U6 minus 5 over 2U1 minus 5 over 2U5. I don't feel like that actually. I don't feel like that actually really gets me anywhere. It just gets me a relationship between U1, U5, and U6, which I don't think will help me too much. I'm sorry to say. But the way that I was working through it, oh, that didn't move the line like I thought it was going to. Whatever. The way that I was working through it, I have two equations and two unknowns now. And so if I multiply in equation 1, if I multiply both sides by 2, I get 170 is equal to 5 times 2u1 plus 4d. And 123 is equal to 3 times 2u1 plus 5d on the right side. So now I have those two equations. Two equations, two unknowns. I can do substitution and elimination here. And so it doesn't matter which method you decide to use. I can just expand this out. And I get these two equations. This one and this one. So I can do, I don't know that either substitution or elimination is particularly easy to do. I'll do substitution actually. If I can divide equation 1 on the left by 10, I get 17 is equal to u1 plus 2d. And that works out nicely because then I can isolate u1. u1 is equal to 17 minus 2d. I'm going to pop that over into this one. 123 is equal to 6 times 17 minus 2d plus 15d. Tidy it up a little bit. 123 is equal to oh my goodness. Should really have like a lozenge or something. What was I doing? 123 is equal to 102 minus 12d plus 15d. And if I gather my like terms, I'm going to get 3d is equal to 123 minus 102, which is 21. So d is equal to 7. If I know d is equal to 7, I can take that back to this equation and get that u1 is equal to 3. Oh, Michael says, isn't it negative 17? Oh, no. So I moved the 2d over to the other side. So I subtracted 2d from both sides. And then I just switched the sides they were on. So I can see what you're saying. I see why you're thinking it should be minus 17, but I didn't move the 17 to the right. I moved the 2d to the left and then just swapped the way I wrote it. So now that I've found U1 and D, technically I can find U2 and U3 without too much trouble. So I don't know if anyone else has any questions about how I got to this part, but I can finish up the question pretty quickly at this stage. U1 is 3, U2 would be 7 further than that, so it would be 10, and U3 would be 17. All right, bye, Emily. Glad you were able to join us. Hope it was helpful. I know studying for math isn't what everyone hopes to do on a snow day, but you know, exams are still on the horizon, so I thought this was worthwhile. Plus, I've always wanted to try it, so I figured it was a decent experiment. Now I know we can do this maybe for final exams too when I'm on the grade 8 trip. Okay. So are we good for question? Which one was this? Question 2? Yeah, question 2 of practice paper 2. Any other follow-up questions about this one before I switch gears to doing the one about a geometric series? Going once, going twice. Uh, okay, I'm assuming Michael's saying yes because he's good to move on. Or yes, he has a follow-up question. I don't know. Please do this for May exam. Oh, Jake, don't even worry. For the actual IB exams, we'll have like a weekend study session and all sorts of stuff. Um, yeah, we go all out for the real IB exams, and it's right before Sophia's birthday too. So, you know, it'll probably be good to do a big study session with maybe some food so that she can forget the pain of doing her IB math exam on her birthday. Um, all right, moving on to question 4 then. In a geometric series, u1 is equal to 1 over 81, u4 is equal to 1 over 3, and we need to find the value of r. So this one's actually kind of similar in a lot of ways. This one doesn't have to do with a series. Like the information that's given is not the sum of the terms in a series. These are actually just the terms in the sequence. So the idea is I have 1 over 81 is the first term, and then I don't know currently the second and third terms, but the fourth term is 1 over 3. Oh, and Coco was here too? Jeez, you guys are so sneaky. You're just popping in and then disappearing. Okay. Bye, Coco. Thanks for stopping by. Anyway, back to this question. So 1 over 81 is the first term, and then I don't know the second and third. Fourth term's a third. So what I can do to connect these values is I know every time I jump from one term to the next in a geometric sequence or series, I'm multiplying by r. So I multiply by r 3 times to get from the first term to the fourth term. So it's u4 is equal to u1 times r cubed. So I know u1, I know u4. If I rearrange this equation, u4 divided by u1 is equal to r cubed. I'm actually now working with an equation that'll actually get me the value of r. I think probably the most difficult part about this one is the fractions. I think that's fair to say. 1 over 81 divided by 1 over 3. A lot of people would look at that and just say, forget it. I don't even want to go there. But the division of those fractions isn't actually as tough as you think it is. In fact, they're picked very purposefully to make sure it works out nicely. So 1 over 81 divided by 1 over 3 is the same as 1 over 81 times 3 over 1. And so this becomes, if you simplify it, 1 over 27. So 1 over 27 is equal to r cubed. If I take the cubed root of 1 over 27, I get 1 over 3 is my r value. Oh, Sophia was here too. Okay, bye, Sophia. So now that I have the r value, that was the first part of the question. So that's 3 marks are in there. Part B is saying find the smallest value of n for which the sum of the first n terms is greater than 40. So what this is essentially saying is you've got this series, and you're adding together the terms, and the sum is getting progressively bigger. um, oh, hang on a minute. I made a mistake here. And I only just realized it because I was thinking to myself, wait, the terms are getting bigger. My common ratio I wrote is 1/3. I goofed because I put U1 over U4 instead of U4 over U1. It should be 1 over 3 on the top and 1 over 81 on the bottom, which means over here when I go to do this division, it's 1 over 3 divided by 1 over 81. So it's actually 1 over 3 times 81 over 1, which is 27. Apologies there if I threw anyone off. So it's 27 is equal to r cubed. So that means that r is actually equal to 3. That makes far more sense. All right, so now that I have the correct r value, I can fill in some of the terms and start to work towards thinking about the sum. So the idea is, if r is 3, my first term is 1 over 81, my second term is 1 over 27, then 1 over 9, then 1 over 3, because I keep multiplying by 3 as I go. So the denominators of those fractions are going to keep getting smaller and smaller. If I multiply by 3 again, I get 1. Multiply by 3 again, I get 3, and so on, right? As I add up those terms, I'm getting progressively larger sums. Not at first, because 1 over 81 is practically nothing. And when I add 1 over 27 to that, it is still pretty small. Couldn't you just do the fourth root of 81? In this instance, you could, Jake, because the way I set it up, the first term and the fourth term are both powers of 3. And so for sure you could in this instance, but I could have very easily thrown a wrench into your plan there by just multiplying all the denominators by 2. If I made it 162 instead, and then later on that 1/3 would be 1/6 instead, that strategy wouldn't work out. And so I want to make sure that you guys are going to use a strategy that'll work regardless of how I set up the question, not only for this specific one. But yeah, you're right. In this instance, it could have worked out that way. Anyway, back to the sum. So the point is you're adding these things together. It starts off with the sum growing very slowly. It's a very small sum. It's only once we start to get past 1 and 3, and the next number would be 9, and so on, that the sum starts to really grow. And I'm looking for the first term in this series that basically, once I've added it into the total, once I've completed that sum, it's now going to finally be bigger than whatever it said it was, 40. It's going to be finally bigger than 40. So if I was to go along and just add what I have written out, I don't get a really large sum. I get 4 point something. So not yet at 40, but as I keep going, right, if I add in the next term, which is a 9, I'm up to 49. Add in the next term, which is a 27, we're now getting a little bit closer. So you could kind of brute force this one, I suppose, because you could just go 9, 27, 81 would be the next term, and then just add them up. So realistically, up till here, it's 13 point something. Once you add 27 into the mix, it's now 40 point something. And so this would be the last term that I would need to do. So 1, 2, 3, 4, 5, 6, 7, 8 terms is what would be needed. But if you wanted to do this more generally, you wanted to solve it algebraically, you're looking for when Sn is greater than 40, and Sn can be found by doing U1 times r to the n minus 1 over r minus 1. So based on the information I know, I can plug in 1 over 81 and take my r value, 3 to the n minus 1, divide that by 3 minus 1. And I want to look to see when that's roughly equal to 40. So 1 over 81 times 3 to the n minus 1 would be equal to 80. So what I did there was I simplified the denominator. I did 3 minus 1 is 2. And then I multiplied that by the 40 to move it to the other side. And then, so this was on a paper too. So at this point, I could just solve this using my calculator. So some people might have solved this graphically. They would graph this part and graph this line and find where they intersect. That's a viable solution. Some people would have continued solving it algebraically until they got to a point where they inevitably needed to use a logarithm. Because if I multiply both sides by 81, I get 3 to the n minus 1 is equal to 6,480. So 3 to the n is equal to 6,481, which I'm pretty sure, I'm just going to double check on my calculator. I do not think that is a power of 3. And in a question like that, honestly, it would probably be risky to even assume that and start playing around with it. Yeah, it's not. So once I have 3 to the n equals 6,481, I would rewrite that as a logarithm. So it's currently in the form a to the x equals b. I'm going to write it in the form log base a of b equals x. And so that means n is equal to log base 3 of 6,481. Technically, you could leave it there, and that's a perfectly exact answer. I would still give you full marks for that. But if this was an application question, and so if this had some sort of real life context and that number connected to something specifically, then you'd have to be a bit more specific, I suppose. And so if I plug that into my calculator, I get that is approximately equal to 7.988 whatever. Bottom line is it's going to round up to 8. Because the 8th term will be the first time, I guess, that I'm officially past 40. But only a little bit past 40. And that's what I was saying before when I just wrote it out. 40 point something was my sum after the 8th term. That's what I've essentially found here. And so that's that question in a nutshell. So I don't know if you guys have any other requests. We're technically past the window of time I said that I was going to be doing the stream, and according to YouTube's little timer up here in the top right of what I'm looking at, we've been going at this for 2 hours and almost 20 minutes. I know that hasn't all been dedicated to DP1 stuff. There was a lot of DP2 questions in the mix, and I don't want to leave you guys high and dry if anyone has any other questions. My understanding is that the way your exams have been rescheduled is that Wednesday's exams, or today's exams, have been moved now to Friday. And so those exams are just going to be shifted till then. Thursday's exams are going to run as scheduled. So worst case scenario, if you do have more math questions, then you can still ask me tomorrow. I will still be around. I have still grade 7 and 8 classes and stuff going on. And of course, if the baby arrives early, then I will be out of commission. But other than that, I'll still be accessible. So I don't want anyone to think that this is a do or die time of if you don't ask your question now, you're out of luck. But I think we are going to wrap up now. So unless anyone has a final question or something, then I guess I will end the stream here. I don't know who's still left. Looks like James, Jake, Trinidad, Ian's heading out. Michael's gonna go take a nap. Sure, yeah, whatever you got to do. Do I teach in the afternoon tomorrow, Jake? Is that what you're asking about? Good question. Let me check. I'm just pulling up my calendar. Tomorrow I will have grade 8 homeroom from 125 to 205. But other than that, the only class I teach is 8A math from 9:55 to 11:15. So I should be more or less free and clear. And originally I was planning on using that time to mark all of your exams, which I would have in hand today if it wasn't a snow day. I'd be marking them right now. But alas, some things are not meant to be. Which is part of the reason why I wanted to do this thing, because I figured if we can do more practice and get your exams that much closer to being correct all the way through, man, that'll be easy for me to mark on the weekend. I gotta figure out how to change the perfect chief time to. Oh my gosh. Jake, Jake, Jake. Um. All right. So I'm gonna wrap up the stream then. I'm pretty sure what happens when this is done, and once I stop streaming to YouTube, I think it will actually upload the video. It'll take a little while to process it, but it'll upload it as is. So if you need to come back and look at something, or if you came late and you missed an explanation and you want to go back and see what I was saying, then you can just wait until the video pops up on the Mr. Grant SJK YouTube channel and see it there. And then, like I said, if anyone has any other questions, I'm assuming we'll be back in school tomorrow. I'm pretty sure a lot of the snow, at least in Waterloo, is melting from what I can see out the window. And so, yeah, I don't think we're gonna have a back-to-back snow day as much as you guys might hope that that would happen. For every snow day you guys hope for, you have to keep in mind that Miss Curry, who has to plan the exams, was probably losing her mind this morning. No problem, Jake. Happy to help, and I will see everyone hopefully tomorrow. If you have any other questions, please make sure you seek me out. Both Miss Daldhart for the DP2s, and then me for both DP2s and DP1. We were a little concerned about how few people we were seeing, so hopefully everyone's feeling like really prepared. Um, Gonna keep my fingers crossed. Maybe I'm being hopelessly optimistic, but I hope this means you guys are feeling really ready to go. So anyway, I'm gonna stop streaming. I think what it'll do then is it will very abruptly shut things down. So it'll cut off everyone from the chat and everything. So I hope everyone else has a good rest of your snow day, and I'll see you tomorrow.